Okay, Pre-Calc Honors, we're going to start Unit 7, which is on polynomial and rational functions. We're going to start by dividing polynomials. So your division algorithm, when you divide f of x, and you divide it by your dividend d of x, you're going to get your quotient, which is q of x, plus your remainder. Your remainder is the r of x, but you write your remainder as a fraction over the dividend d of x. Okay, so now let's just put a box around that. If you were to multiply both sides of that equation by d of x, then you would get this equivalent equation here, f of x equals d of x times q of x plus r of x. So now let's do some long division. We're dividing by x squared minus 4, and we're dividing 3x squared minus 3x cubed minus 2x squared. We don't have a linear term, so we'll put in 0x minus 150. So when you're dividing, just look at the first terms, 3x cubed divided by x squared, and that's 3x. Then multiply 3x times x squared minus 4, we get 3x cubed minus 12x. And then you subtract. So we get negative 2x squared minus negative 12x is plus 12x. Okay, and next we want to think about negative 2x squared divided by x squared. We get negative 2. Oh, and I did forget to bring down the minus 150 in my last step. Okay, so negative 2 times x squared is negative 2x squared. Negative 2 times negative 4 is plus 8. And you want to subtract. So I get 12x minus 158 as my remainder. So then down below, we're going to write the whole statement. So my f of x was 3x cubed minus 2x squared minus 150 divided by d of x, which was x squared minus 4. It's going to give me my quotient, 3x minus 2, plus my remainder, 12x minus 158 over x squared minus 4. So when you're looking back up at the top and trying to match things up, here's your f of x. Okay, and then below is your d of x. And that also shows up under the remainder. Okay, and then 3x minus 2 is q of x. And then the remainder is the r of x, and that's the 12x minus 158. Okay, next page. So we can use synthetic division when we have a divisor that is a first degree polynomial in the form x minus k. And that is definitely needed for synthetic division, but when the coefficient of x is not 1, that is a fixable situation, and if you forget how you fixed that in Algebra 2, please ask me about that in class. Okay, so in synthetic division, you're going to take the 0 of x plus 2, which is negative 2, and you put that in the box, and then you put the coefficients of your dividends. So let's see, we need 3. And we don't have an x cubed, so that would be a 0, negative 8, negative 11, and 1. Bring down the first number, 3, and then multiply negative 2 times 3, and then add. Multiply negative 2 times negative 6, and then add. Multiply negative 2 times 4, add. And multiply negative 2 times negative 19, and add. And this last number gets separated because it's special, it's the remainder. So when you divide a 4th degree polynomial by a 1st degree polynomial, we lose exactly 1 degree. So your answer is going to be 3x cubed minus 6x squared plus 4x minus 19, and then you want to write your remainder as a fraction over the divisor, which was x plus 2. So I want you to pause the video for a minute and try the next example on your own, and then check back and see how you did. Alright, so hopefully you already did this example. You put positive 1 in the box, and then you put your coefficients to -1, 2, -3. Bring down the first, multiply, add, multiply, add, multiply, add, and this time your remainder is 0, which means that x minus 1 divided evenly into your polynomial. So your answer is 2x squared plus x plus 3. All right, so the remainder theorem is something you can use to evaluate f of some number x, and if it's going to be too difficult with all the powers. For example, f of -3, if you were to plug this into your polynomial, you would have to do -3 to the 4th, which could be kind of tricky. So another way to do that is you're going to use the remainder when you divide by x plus 3. So if you divide by x plus 3, you do put -3 in the box, and you put your coefficients -1, 0, 3, -4, -5. Bring down the first one, and multiply, add, multiply, add. So 3, -9, 14, and your remainder is -47. So the answer to f of -3 is the remainder, -47. Okay, moving on. A zero polynomial function f of x is a number k such that f of k equals 0. They're also called the roots, and the zeros are the x-intercepts when they are real. Okay, so to find out if 1 is a zero of the polynomial, we want to divide by x minus 1 and see if the remainder is 0. So put 1 in the box and write your coefficients. 1, -4, 9, -6, and multiply and add. And the remainder is 0, so yes, 1 is a 0 of the polynomial. So pause the video, try the next example, and then check back and see if you got it right. So we're going to divide by x plus 4. -4 goes in the box. 1, 0, 1, -3, 1. So the numbers are slowly getting very big, and you're going to figure out pretty soon that this is not a 0. But just to prove it, we're going to find the actual value for f of -4. And it's 289. So no, -4 is not a 0. All right, and we're done with your notes. Bring those to class with you. Thanks.